Okay, so in the last one we saw a function. It was actually 2x, where we got a negative a negative area. Again, this is not actually what the area is. It's what the signed area is. So signed meaning this this part above the x-axis is positive, and this one below the x-axis is negative. And so if you have some above, some below, or even if you just have some below, what you can get as a final answer is a negative number. So let's think about what this means. So let's say you have a similar one where you let's say this area down here has an actual area of 12. Like if we calculate it using the area of a triangle or something, and this one has an area of 7. What this means is the net just means final result. Okay, so the final result is we would have negative 12 plus 7, in other words, negative 5. Okay, so you can have a net of a negative area as your final result. Net meaning you add up the different values and you see what you get. Okay, but think about it. If these were just random floating triangles, we could find their area. And if we actually were looking for what is the area of this shape plus the area of this shape, we would be looking for total area, which would be, in fact, 12 plus 7, or in other words, 19. Okay, so there are some times where total area is going to be a thing, but when you are just doing the actual integral from a to b of f of x dx, it is automatically doing the net signed area, which can just spit out a negative 5 for you, and that doesn't actually represent a geometric area of two shapes, or even just one shape. It represents also whether the area is below or above the x-axis or not. So so let's save how to transition from one to the other for another time. Yes, let's save that for another time. Yeah. So I've already shown that if the y values are negative, then that can make the net signed area be negative. There's another way that you can do that and have to deal with that, and that is related to the areas we were just talking about. So let's say you get your negative 5 after you take the integral from a to b, and you don't know how to deal with that. What do you do? How would you actually find the total area? Well, if you could figure out that it was negative 12 plus 7, what you could do is take the absolute value of all of the pieces, and that would give you your total area again, because it makes each thing positive. So that's kind of what would happen. The other way you could find the total area from these two things is to anything that's negative, change it to be negative, change it to a negative sign. So that's related to what we're going to talk about now, but struggling with the transition here. Okay, so we talked about the y values, but what about this rule that a has to be less than b? So we know that delta x is b minus a over n. How could this be negative? If this was less than 0, what that would mean is for delta x to be negative, a would have to be bigger than b. In other words, normally you're going from a to b, which is a positive direction for delta x. If a was bigger than b, that would mean, like I was saying in the previous video, you're starting at a, this is always your starting point, and you're going backwards to be here. And so then that's an example. That example I used was like going from, let's say 20 to 0. And well, what's your delta x then? Delta x would have to be, well, the upper limit, 0, minus the lower limit of 20 over n. In other words, negative 20 over n. Look, now the net delta x is negative, and it's because you're traveling in the opposite direction. So one of the ways, there are two ways to think about this. But let's just actually write out what we have here so far. So so let's make this a little bit more general. If you have the integral from a to b of f of x dx, that is always equal to negative the integral from b to a of f of x dx. Now, why is that? Well, all you have switched is the order in which you are doing things. Okay, so let's say here you have a, right? A and B, and you're going from A to B. Oops. Okay, it's a confusing situation. All right, so this is the normal one. We're starting at A, we're going to B. Okay. And then here we have switched it. Now we're going from B, which is here, to A. In other words, we're going backwards. We're going, this is a negative direction, this is a positive direction. And nothing else has changed, right? Every single thing, every single step of the process will be exactly the same, except, right, all of this whole process and finding the sum would be the same, except that the delta x out front, the constant out front, would just be negative whatever it is instead of positive whatever it is. Like if this difference, let's say, was, positive half, if that's what delta x was, then going the opposite direction, it would just be negative a half. And so you can change the entire well, if you change the direction in which you're going, then you have to change the sign as well because you've changed the direction. And this works regardless of whether A is the smaller one or not. Okay, so let's say here that A is in fact bigger than B. What that means is this will spit out a negative number, like say negative 17. Okay, well then that means if we switch the order, right, so we've got A is actually bigger than B. So to go from A to B, it's going in the wrong direction, gives us a negative number, even though maybe it's a positive function, but we're going in the wrong direction, so it gives us a negative number. Then for the exact same function, if we go the correct direction from B to A, then that will just give us the positive 17. The area hasn't changed, just the sign of the area has changed. Okay. So yes, there are two different ways to think about this. Like I've said, one of them is to think about the actual direction of that you are traveling. Personally, this aspect of things gets very confusing, so I don't entirely recommend that, but it can help you understand what's going on. The other way to think about it is you must always have the lower part be bigger than the upper part. And so if you have something like the integral from 5 to 2 of x dx or something like that, you must rewrite that as negative the integral from 2 to 5 x dx, and then proceed. This is what I recommend. Just always keep the lower bound smaller than the upper bound, because you're going from lower to upper. And so it doesn't make sense to have 5 as a lower bound when you're going down towards 2. That just kind of doesn't make sense. So really this is a trick to help make bounds agree with each other, and to make the lower bound, in this case B, be less than the upper bound, which in this case is A. So if you ever get into a situation like this should be error. I need to change it. I need to switch the order. And when you switch the order, what you've done really is you've switched the direction of travel. You haven't changed the actual area. So that's why the sign would change. So that's one of the things that can get confusing is you need to know that if you have bounds that, if you have a bound that is, if you ever get into a situation where you need to change the order of the bounds, upper and lower, you can do so. What it does is it just makes the whole thing negative.